Here's the plot of our results. Good, making sense? Now, Josh brings up a good point. I want to make sure you guys hear this point. Good. Set the mood lighting for a second here. So, you have an option when you're making scatter plots to pick the symbol that's the plot dot. Excel has vastly more. You can actually make little pictures be your dots. Anyway, so this guy right here, if you set your plot up, if you set it on, for example, a little plus sign, and then you press graph, it's kind of hard to see these guys over here sometimes. And if you use the other symbol, the dot, this is my least favorite, they kind of disappear altogether. So yeah, exactly. I like to make the most obtrusive one, which is the square here. Now Excel does a much better job of scatter plots than the TI does, but most of us aren't carrying Excel around with us. Cool. Did you guys make me a curve that fits it? How many of you went with the best fit line? You said, hey, let's make a linear regression. Could you? Of course you could, right? Of course you could do that. I mean, sure. You could just go stat cap lin reg y1. I don't know where these buttons came from. Max was playing with my TI. There's your best fit line. There we go. That describes the data pretty well, right? Except it doesn't. Except it doesn't, right? That's the average idea. That's the averaging idea. That's like saying it took us this many flips completely to get the number of 186 heads, or whatever it was, yeah, 186 heads. But we're going to average it out. So in other words, Desiree 13 gets averaged in with all those ones, then it doesn't make any sense, right? Because it loses the shape of the curve. So linear regression's no good. I agree. What should you try next? Quadratic regression. Love it. Love it. Quadratic. Let's do it. Quadrag, y1 again, yes? Here's our quadrag, yes? Much nicer. Much nicer. It's got the curve, right? It follows the curve down. Give me one problem with it.
Back up.
Oh! Christy says one problem is it goes back up. Why is that a problem, Christy? Because, go ahead, something's not sitting right with you. What's not sitting right with you?
Because you're not flipping anymore.
Because, remember what happened to Desiree when she flipped 13 times to get ahead? I mean, she had to flip tails 12 times to be the 13th to be heads, right? So that's that. And we were surprised by that. I was wickedly surprised by that. That's why, again, I was so like, wait a minute, 2 9s, 2 8s, 2 7s. As we started getting higher in the flips, what was happening to the number of times that happened? It was getting smaller, correct? So if we use the quadratic model, what it's telling us to expect is, it's telling us that we should be expecting what to happen as we go this way? More people flipping more times to get to a head. In other words, here's the low point right here. And then when we start getting out to 14 and 15 and 16 and 17, we're going to be having more people. Remember what you're looking at, X and Y. X is, let's draw this on the board. This right here is number of flips, correct? That's the number of flips. What's on the vertical? Go ahead, say that again. What's on the vertical? What are we actually looking at on the Y there? Number of heads. Number of trials where we saw that many flips. So in other words, this data point right here. Let's go to that data point. I think you're saying the right thing, Ashley. I want to say it a little more concisely. Just be more concisely.
I don't really understand what we're doing.
Don't you worry. We're going to figure it out right now. This data point is 182. What does that mean? Interpret that for me. Exactly, but in context, what does it mean, 182 with respect to our experiment?
That
Anya, go. You got this.
That it took one time to get to heads 82 times.
Yes, ma'am. 82 times in this room, it took exactly one time to flip heads. You got it. You said it exactly correctly. So what this is, it's the number of times to get heads after x flips. It's weird to say it that way, but I'm trying to tie y to x. So what's happening with each successive x increase as x goes from 1 to 2, from 2 to 3, from 3 to 4? What happened with our data? What was happening? What are happening to the y values? They're getting smaller. They're getting smaller. Should they go back up past the point?
Probably not.
I would. Who said that? Probably not. Very good answer. Because I was just here ready to say they could, right? It could be if I had you guys flip the coins, oh, I don't know, a few hundred times more. Maybe we start getting 19 and 20 and 21. Desiree starts going, why did I come to class today? Right? But probably not, right? Give me a reason as to probably why not. What would it mean if we were able to get out here to say x equals 20 and 21 and 22 and 23? What would that mean, Christy?
Well, I'm thinking there's a 50% chance that you can get heads each time, so why would it ever take that many?
Wait a minute. Say that again. Say that again. I was drinking coffee. I didn't quite catch all of it.
That there's a 50% chance of getting heads every time you flip it, so why would it go that high?
So why would you have to flip tails so many times if the coin was 50-50? Well, good. That explains quite a bit, actually. That explains little random fluctuations, which is the beginning of next week. Stay tuned for that. Yes. But the thing is that we shouldn't expect past the point to start flipping more to get to heads. As a matter of fact, let's think about this algebraically, shall we? Let's think about this. I'm going to turn this off and go back to the Excel sheet, which you can't see because I'm pointing to a screen you can't see. There we go. So here's our data right here. The same data you guys put into your TIs, yes? Okay. 186 of us. Let's pretend there's 186 people in the room, just because that's fun. It's fun to think that 105 is that wildly popular. 186 of us all took a coin and went shink, and then and we watched it hit the ground. You lost your coin? I'm sorry. We'll get you another one. 82 are left, right? Did you remember what Christy said about how it's a 50% chance of heads and a 50% chance of tails? So what does that mean?
It means like every time you flip, you look at it like 50% chance, 50% chance, 50% chance every time. So theoretically.
So how should these? I love what you're saying. How should these numbers be related to each other?
About half.
About half? Let me. I love that, Amy. I'm going to use Excel to check it. Well, you know what? The hell with that. Forget Excel. We'll get Excel in a second. This should be about divided by 2, shouldn't it? Because if you think about it, half of us flipped heads on that first one. We should have, according to Christy's 50%, which I love, by the way, and Amy's analysis. The rest of us are going to flip again to try to get heads the next time. Does that make sense? So roughly half of you were done after one flip. The other half are going to keep going. But of those, what's going to happen between that and the next? Well, it should be half again, right? It should be half again. And then from here to here, it should be... So what's happening is you're getting this repeated division by 2. Now, is it perfect?
Maybe by average, it might be.
Say that again, if you don't mind.
It isn't perfect, but on average, it's probably.
Oh, God! The pride I feel right now. It's not perfect because you guys aren't flipping exactly 50%. But are we averaging 50%? Now that's what I want to analyze that today. Can we create an equation that models this? Can we create an equation that models this? What I want to do, remember how we just ran lim reg and quad reg? Let's not use the machines to do it at first. Let's actually build this one from scratch, if that's okay with you guys. If that's okay with you guys, I want to build it from scratch. Oh, it's okay. It's going to hurt much less than the other ones. Because the other ones, the lim reg and the quad reg, they're a pain in the butt to do by hand. This one, we can actually get a pretty good fit without having to use the machines at all, just by kind of reasoning through what Amy and Ashley's over here, and Christy just said. Cool? So let's take this away for a second. Now we know that when, I'm going to create what's called a theoretical over here. Theoretical. We know when we started, we had 186 flips to go. Theoretically, if we went with exactly that 50%, let's just go with a theory for a second. Exactly 50% after 1, how many should be done after 1?
93.
93 would be exactly half, yes? Good. 93. Now, how did you guys get that? Gesundheit. How did you guys get that 93? Good. 186 divided by 2. Can I write it a slightly different way? Just a smidge of a different way? I want to do 186 times 1/2, if that's okay with you guys. It's going to jump out more if we do it that way, and I think multiplication is viewed a little more happily than division for most students. Just like addition is slightly better than subtraction, I think multiplication makes students happier. My opinion, and just my anecdotal kind of evidence. All right. Now, if we were being exactly halving, what would the next number be after 2 flips?
46.5.
What would that be?
46.5.
46.5! I second that. 46.5? 46.5, yes? Does that make sense? Okay, good. Now, how did you calculate that one, Amy, so quickly?
Half of 93.
Ah, half of 93?
5 and then half of 3 is 1.
Oh, can I do it a different way?
Of course.
No. Well, watch. I think it's the same way, actually. 186 times a half.
Are
Times a
we
half.
turning this in? I'm
We
writing
turning-
all over it.
No, keep writing. This is your notes. These are your notes. I've got other in-class stuff for us to do. This is kind of a learning procedure, right? I don't want you to turn in learning procedures. You see what I did? You see what Amy did first? She went back to the previous and took half of it. And I said, hell, we could refer back to the original one and just take half of it twice. Do you see how they're the same? Do you see how they're the same? Before we go any further, make sure we buy that. Amy looked back 1, I looked back 2. But we get to the same point. I just didn't have to do an intermediate step. Is that fair? Believable? You might not see why right now. Don't worry about that. We'll get to that in a second. Promise. Okay, how about after 3?
23
23 1/4? I agree with that. If we cut 46.5 in half, 23 1/4, yes. Which of course would be 46.5 halved, but of course because I'm me, I'm going to do it as 186 times what?
1/8.
Oh, good. Can I write it out like this, Josh, for now?
You could.
I love where you're going with that, though. Don't lose that. Don't let that stray too far. Do you see a pattern, friends?
Your halves keep going up
Oh,
by a half.
up by, okay, so with each successive x that goes up by 1, I love what you're saying. With each successive x that goes up by 1, I do one more what?
Half that.
Good, one more factor of 1/2. So watch this, the beauty of this is, I don't even have to know what the decimal is going to be, although it's going to be what, 12.75, I think, or something, I don't even know. To hell with it, I'm not doing it. Because all I got to know is, I start with my 186 and multiply it by a half 4 times. Say that again. Oh, actually, hold that thought, Jordan. Hold that thought. I want to get one more thought in before, because I love what you're saying. It ties into what Josh is saying, but you're being even more general. Now, the reason I like writing it like this, is because you can see the whole process of the experiment in one line. Here's how we started. After the first flip, we lost half of the crew. After one more flip, we lost a quarter, then an eighth, then a 16th. Eventually, they're all going to be gone. But theoretically, they don't have to be. There could have been someone in the room that's still flipping right now, right? Tails, 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 tails. Like on The Simpsons, I got hiccups for like 5.5 years. Kill me, kill me. Flip, flip, tails, tails, tails. It could happen theoretically. It just probably won't happen. It probably won't happen, right? So now here's the question. I think we now see the pattern, because it's getting a little ridiculous. If we have to keep writing these halves, your hand's going to get tired. Well, this is why we invented what in mathematics?
Exponentials.
Yes, we invented exponentials. So this, technically speaking, is just 186 times 1/2 to the first power, which nobody's going to write it like that. Let me change color too, because we have colors. Why not? Let's do that. Okay. 186 times 1/2 to the first. This is 186 times 1/2 squared. We killed this, we can see a little better. 186 times 1/2 cubed, or to the third. 186 times 1/2 to the fourth. So now we're tying Josh's idea in. Jury says, I think we can jump right to the generalization though, can't we? What happens if I go out to some unknown number of flips? X could be 1, it could be 2, it could be 3, it could be 4. What would the equation look like if I didn't want to specify exactly how many flips? In other words, if I was interested in the number of flips and studying them. Jury, go ahead.
It's 186 parentheses 1/2 exponent x.
Oh, look at that. Isn't that the only thing that's changing? The only thing that's changing in this exercise is the number of flips, which is the number of times the half is applied. After 4 flips, we've applied the half 4 times, because with each successive flip, we're losing half of those that remain. On average, as Amy said, not exactly, but on average, we're losing half those that remain on average. And I love this. I love it, 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 except it seems to be broken right here, doesn't it? Can we use the equation here? Say yes.
Technically, yes. because
Say, don't even say technically, just say yes.
Yes.
How come?
Because we said so.
it's x.
Well, because I told you to say yes, that's true.
Well, when you multiply anything by 0, it's 0.
But we're not multiplying by 0.
No, sorry.
We're raising to the 0 power. So this is where I'm going to be a bastard. I'm going to make you remember your math. 95, maybe 65. Here comes a bastard move. You ready? Here we go. Will the function work up there? It would be 186 times 1/2 to the 0 power. What is any number to the 0 power except 0 itself? Go ahead, Christy, you remember?
1.
1, Amber's saying 1? It is 1, isn't it? It is 1. Anything to the 0 power except 0 is 1. So this is really just 186 times 1, which is 186. Hot damn, I'm happy. Can you explain to me why something to the 0 power is 1?
Because you're not, you're not multiplying it by anything. You're multiplying it essentially by.
Why would it be 0 then? I love that answer. I love, okay, that's the reason I want to break today. I want to break that today, if that's okay, Ashley. I love the fact that you're saying it's just there. I want to make sure you understand why it's just there. I love that you said that, by the way, thank you. And Jury, I'm picking on you too, because thank you for answering. I love your answer. But if it seems like if you're not multiplying anything, it should be 0, not 1, right?
Yeah.
Does anybody remember